So perhaps about last year, I joined the Sysdig family because you love security, you love monitoring, and you love open source. It's something like giving into a monkey a fork and putting some place of food in front of. It's the natural path of yourself. Another thing about me is that I am the daddy of twins, and that means that 20 months ago I was gifted with two lovely kids, a little girl and a little boy. And I also was gifted with an enormous amount of patience. That means that if you have some question, please stop me and ask without any kind of problem. On the other hand, that's not free because I can barely sleep at night from all that time. So I also the maintainer and the author of Sysdig Falco and also for the Falco one. And recently, I also did some work for the Sysdig and Falco operators. And finally, I'm a judo and aikido practitioner and lover. We spend a lot of time seated, and it's pretty good to get some movement, to do something for our health. So that's my part. What about you? I want to know how many of you have some kind of containers deploy in production. I mean, oh, that's cool. That's cool. I usually ask that because I can change my speech more or less for adapting to all people. So in this presentation, I am going to show you about a little several notions about security. We are going to talk about what is a security pipeline. We are going to see the different kind of things we can do at real time, on shift time, or on runtime. And finally, I will do a little demo with a response engine for automating security playbooks over Kubernetes. I will explain a bit later. So first things first. Container security. Perhaps if you have read any kind of security book or similar, or even if the networks book from Tannenbaum, you could get to several conclusions like this. You have to see the difference in your different environments. It's not the same to secure a staging environment than a production one, and you have to know the limits about how the different parts are talking with each other. The next step is also about a book. You need to minimize the attack surface. I mean, you need to harden all the security to not expose more things like needed. It's the same for the scope. You have to get the protections, and also the last one, which is also important. I'm not going to cover that in this talk. Is about the traceability and test. We must know everything that is happening in our system when we receive an attack, and we should be able to reconstruct everything that is happening, everything that happened in the system, because it's something like. I don't know. I think that here in France there is also that series. Do you know Grissom, the CSA Miami, CSA Vega? Imagine Grissom doing their stuff with the dead bodies, and then the body suddenly disappears. How Grissom can't do anything for knowing what happened to that body. Well, this is one of the things that is important with containers. I mean, containers change a little bit the rules of security. And one of the things is about its ephemeral nature. I mean, a container is not like managing a virtual machine or like managing a bare metal machine. It's absolutely different. In fact, last year we get several data from our customers, and the mean time for the mean time life cycle of a container was about 7 days. 7 days. That means that you can receive an attack and never notice you were attacked. So this is also important. I also love to see the first one. I have colleagues that work on marketing too. That work on marketing, and many security paradigms are still reactive. What does it mean? Like I hear Zaragoza in the público, in the room. I mean, in Spanish we have a popular saying that it's that nos acordamos de Santa Bárbara cuando truena, and that means that I'm going to translate it literally. We remembered about Santa Barbara when we hear the thunderstorm. The explication for that is that Santa Barbara is the virgin of the sailors. Then, when we are in a boat, we are navigating in the sea, we start to see the lightning bolts or hearing the thunderbolts, and we start to pray, please, please, please keep me alive, because we are going to have a bad time. This is quite similar. All of us are going to be attacked and are going to be hacked in some moment of time. But we need to put some work before that happens, not to wait. We have to consider security right here, right now. No, we cannot wait until we receive an attack, because you are going to be in a stressful situation. You are not being your best situation for thinking. So, and the last one is about that also containers has emerged about another kind of attacks that tries to abuse your infrastructure instead of data exfiltration. Perhaps most of you remembers about the Ashley Madison scandal when someone stole several email addresses from that dating site. But also, I remember in one of my first customers, my public work when joined Sysdig was about a guy that deployed a Kubernetes cluster on AWS. It deployed fine with the auto-scaling groups. It used, in fact, actually the FTO CloudFormation stack. It was a pretty good deployment. And we were talking with her because the previous month he received a $25,000 bill for their Amazon Web Service. Because someone entered into the system, access to the Kubernetes API, and start to spawn mining pods. You know, mining pods is hard, is inexpensive, is going to cost you some money. But if you do it with others' money, it's really more cheaper. So this is one of the challenge. This is a summary of the challenges that we have now with security and containers. Also, the next part is about the pipeline security. I mean, there's another new term in the world. Perhaps you know you have heard about DevOps. It's perhaps one of the most overloaded and perhaps perverted terms in the industry. That DevOps is not about having a team of operations and a team of developments and call the operations about. No, it's DevOps instead of ops. No, it's not. It's not that the point. In that case, we want to do the same thing also with security. We want that the operation people collaborates with the developers and also with the security ones. We need to change all the mentality because we are together in the same boat. If we are going to have a problem with security, our service is going to suffer, and well, in some cases, in most of cases, that means that we are going to lose money. Also, we need to focus, like the developers did, just about augmenting the pace of deployment that they can do, doing the same from a reaction to a security breach. What about if we, instead of reacting in a week, or just imagine that we detect a security breach, and we say something that, okay, add a ticket to the Jira, and it will be resolved. When? Well, how much time is going to happen between the two milestones? I mean, it's a bit complex. And also, this we need to scale this process to big environments. We can do this for some clusters that are about 300 nodes. It's no sense. You can't do it by hand. You need to automate the things. And finally, these are some practices I have identified with DevSecOps. We need to adapt, like I said before, adapt the process to bring the agility into the security world. And when I mean agility, I'm not referring about doing the stand-ups, doing sprints. No, it's not about the game. It's about being able to react to the changes and solve them well and make it our best. The next one is security as code. The same things that work as developers, as DevOps, can work here too. And also, the failure is the example that I put before, that open a issue in Jira or just breaking the build. Imagine if we will take a bit later about image scanning and the CI step. But for all of this, like everything is not a revealer, we need to have a technical excellence. We cannot do it with just bad knowledge or. Okay, at build time. What we can do at build time? Oh, I forget to put the clock. Okay, I'm going to do it now. Sorry. Okay. More about 15 minutes, more or less. Okay. Okay, image scanning. When we build our container in our pipeline, we can do this kind of checking. But this is a bit tricky because we are going to look for all of these points. The first one, vulnerabilities, but not only the vulnerabilities that the operating system can report us. That are the easier ones. I also referring about the vulnerabilities in your Python libraries, if you use Python, in Maven, Ruby gems, also in the binaries, we can do that kind of checking. We also can find deprecated software, configurations that are not secure. That one I bolded because the credentials leaking. If you raise a search to GitHub looking for a password, you are going to see a lot of passwords. We cannot tolerate that kind of things. Insecure permission or sensitive files. I remember this case when I was younger and I did several Ruby on Rails development. Well, I remember the database .yaml config having in the Git. It's okay. We need to take this seriously. And finally, it's a good place to introduce compliance. Compliance is going to it's about that put some rules in that all our containers that are going to go out from our pipeline, that they are compliant with several rules. I mean, we need to put some internal quality standards. And finally, that's in fact the HashiCorp guys released a tool a few months ago about checking software license. We can do everything of this when we build the container. But also, having addressing all of these issues at once, it's a bit hard. So we want to, as a users, we want to whitelist or blacklist some of them. There are some issues that can be blocking and others no. For example, and also, specific file permissions that are related to our own application. I mean, there are things that we can secure, or we can know how to secure an Nginx or other kind of products. But when you are doing another kind of internal development, you know your application, and you have to think about how to secure it. Also, we have some Dockerfile tips that, more of these are well known, but I want to remark the user directive. If you don't put a user directive, that container is going to be run as root. Yeah. And I remember perhaps last year KubeCon in Denmark, I remember I saw a talk that she said that about the 86% of the Docker images in Docker Hub doesn't contain a user directive. So that means that are the major part of the images secured? No, in fact, it's the opposite. the almost majority of the Docker files are going to be vulnerable. Also, you need to reduce the surface attack. Don't install packages that you are not going to need. And also, this one is also important about the reproducibility and images, that please avoid also doing things like wget, uwget, and getting some packages from some URLs. Because if you are going to retry to build that image is different. Also, image scanning is pretty cool. It is going to address a lot of things, but it's not enough for covering all the possibility risk. I mean, container images are immutable, but when you put the container in production, it's going to have some, we call operational drift. It's going to start rotting, for saying in some way. Because the application perhaps is going to write some files, is going to write logs. Is not any guarantee that the runtime is going to behave in some cases equal. I mean, there's also memory leaks. There also can have bugs. Also, if we receive a 0-day attack, we need to how we can detect that 0-day attack. I mean, a new vulnerability has been discovered, and we have all of containers running in production. So if we detect a new attack, perhaps we don't know if that image has the bug or not. I mean, we need another layer of security. And this is the case for the runtime security. I also included the CPing one because CPing is easy and is a part of the pipeline tool. But there's only one slide here. Enable the image syncing. I mean, you can sync your images and make sure that you are using signed images. Trust only your registries, not the ones that you are deploying, but for example, if you are using Quay or if you are using the OpenShift internal one, you can trust it, but try to avoid to install from several pieces for several parts that you don't know. It's quite similar like a mobile phone. You have in Android, you have to give a specific permission for installing software from other parts. And also restrict the access to the continuous integration or continuous delivery tool. Perhaps in a perfect world, that all of this must be done by a script. Okay, now we can skip a little bit on Kubernetes. Kubernetes offers us several features that we can use to secure or running environment. I mean, for example, one of these, the RBAC, the role-based. In this case, I don't know how familiar are you with RBAC, but in the gray part, in the blue part are the subjects, the user, the group, or the service account that can access to a resource, that is this gray one. And here there are two verbs, a get and a list one. That means that we are going to bind these specific permissions. I'm going to add these permissions to a role, and I can authorize a user to use this role. This is the diagram, and this is how it's read. I mean, you have the first one, the role, this is the same example that is in this diagram. It's here. You have the verbs. You can access to the pods. This is the role that it's called pod reader. And here you are binding a user with that role. Doing this kind of things, for example, would prevent the attack that one of the first clients I saw in Sysdig received. It was still a proof of concept. I mean, perhaps if we secure them, we could avoid that attack. But this is one part, the RBAC. The second one is in the pod security policies, the PSP. The PSP are going to offer some mechanisms to secure your pods. I mean, for example, you can control if with a PSP running some privileged containers, which user who are going to run one pod or another. The PSP also can control who or if the user or if the runner can access to the host file system or host network, and this is more or less the aspect that has a PSP. We can see here the run as user, the privilege. Oh, I have two screens. Well, okay. The host network, the different type of access that you can have. And also, we have admission controllers, and the admission controller is going. This is the behavior about the intercepting the request to the AP server, but it's going to allow you to avoid several kind of container. Is going to avoid to run several kind of containers that can be malicious or malicious. Or imagine, for example, a kind of integration about that if we detect if we detect a vulnerability at runtime, we can also instruct the Kubernetes using an admission controller to avoid to run that container again in another cluster. I mean, we can detect that a container has been compromised. Then I can get the image and directly forbid that image will be running in the cluster using an admission controller. This is the internal behavior. We're going to receive an API request, first the authorization, there is trying to mutate, then the validation, and here there are webhooks to control the admission. I mean, there are different types. For example, the one that I just explained about the image policy webhook, we can use this admission controller to control which images we want to run. We also can have several ones for resource quota to avoid giving too much, to forbid to schedule some pods that can be resource hungry. And also, on the last place, we have the pod security police, the old friend before, that is also an admission controller. So we can control to avoid, for example, that, to avoid privileged containers, or to avoid we can control all the stuff that is going to be scheduled. Is the summary. Finally, we also have an anomaly detection that is the other layer in the security stack. We talk about the image scanning, the build time, and also in runtime, in our application runtime, we can have this kind of problems. The first one is that perhaps you already know that you can see containers like some kind of isolated process. In fact, in the Linux kernel, there's no any kind of container abstraction. So it's just a process with its C groups and its namespaces. Also, repeating the same stuff I said before, that the images are immutable, the containers not. The containers are going to receive inputs, are going to process several things, and it can change. And the question is about how do you detect this abnormal behavior? Well, I'm going to talk here about an open source tool. I'm the Falco. Perhaps I mentioned earlier in the presentation. Falco is a behavioral activity monitor. That means that we can detect suspicious activity at runtime. Later I will explain you how it's done. But basically, we can see suspicious activity, like, for example, if someone is trying to write something in your bind directory, or if someone is trying to open a connection to an unexpected place, or if someone is trying to execute something in your container. These are things that smell a bit, that can be malicious. The good stuff is that it's aware about containers and orchestration. You know, it can actually uses the Kubernetes metadata for well, I will explain a bit later. For matching the information, the low-level information. I will talk about that later. We have flexible notification methods. Once we detect an alert, we can send it whatever we want. And the nice stuff about this is open source. It's actually a CNCF sandbox project. And that contributors are welcome. So I'm going to try to convince you to contribute some stuff. So how it's done? Well, Falco, it's pretty nice because it's just a pod it's a daemon set. I mean, it's only there's a pod on every host on every host in your kernel. So we can have one application, the application you are developing right now in your company. We can have also an Nginx, an Nginx, an HA proxy, whatever on top of that or not on top is the same. But Falco is going to use a kernel module or an eBPF proof, and it's going to capture all the system calls that are happening in the host. At the end, yes, containers, Kubernetes, yes, at the end, you have to execute the things. I mean, you have to open a file, you have to open a connection, you have to execute a program. I mean, Falco uses all that low-level information and mixes it with the Kubernetes metadata for knowing which pod and which process is issuing every system call. There's a ton of data, yes, but well, it's mostly working. This is another diagram about how Falco works. In this part, we can see the module and the eBPF proof. That is the source of the kernel module of the system calls, the system call source, and we use the Sysdig, the open source tool for interpreting for putting some sense in all the system calls, and also we are starting to receive another kind of stream of events. For example, in this case, the audit logs. Kubernetes also is going to log every kind of operation that you are doing with the objects. That means, a practical example, if you are going to create a config map with a password, that is going to be logged. And we can detect also that kind of behavior. If you are going to store a password, use a secret. Don't use a config map. I mean, well, on top of that, of all these events, we have a little rules engine that, using several expressions, can raise alerts. I mean, for example, we can detect that we are opening a file to write. Okay, this is not a problem unless we are trying to write on bind directory, or we can read about any file on our file system. But if the system started and suddenly we start to notice that we are seeing activity like something is trying to read the etc shadow, it is suspicious. I mean, of if you are storing, you use a config file for keeping your database configuration, and someone is trying to read it, which is not the process itself that should do it, it's suspicious. And then we can craft custom alerts to do that. Then, once we receive an alert, we can notify, just using the shell, using the standard output, using the syslog, using mostly whatever we want. So, this is an overview about Falco. And finally, I'm going to talk about the response engine. Falco is doing a pretty good job detecting things at runtime. But what about the next step? You are going to have here some people looking at the logs directly, or that doesn't work. So imagine you have this problem in a big cluster, about 300, 350 nodes, and you receive that you have a container in your shell. In which cell? In which machine? In which? Well, it's something like look for a needle in a big surface. It's going to be hard. So the thing about responding a security incident is that a security incident is a stressful moment in your life. When you have had one of them, you remember all your life, you know, and that should not be improvised. Okay, I mean, you cannot try to see what's happening here, what's happening there, and perhaps you are doing more damage than you are more harmful that you are trying to save. I mean, then it's important to do this in a responsible way, with some responsibility. I mean, to make it consistent, focused, and the problem with that is, in fact, that perhaps you shouldn't trust in a human to do that. We know that machines are the best tool to execute this kind of politics. And well, we did a little project, this little project. In this part, I have the Falco container piped with a sidecar. This sidecar is going to publish the alert to NATS. It's perhaps NATS is a message broker built to run on Kubernetes, and I'm going to subscribe every kind of reaction like a function using kubeless. That means that I'm going to have, I'm going to show you directly. Okay. Oh. Okay. Here, I can have, it's more, I'm going to show you just directly some kind of playbooks that just are going to delete a pod, publish the message to Slack, perhaps tainting a node if the attack reach also the machine that is hosting the application I mean, we can taint a node to avoid to schedule more pods in that machine. Also, we can to do some kind of network isolation. Well, this is a predefined set of playbooks that are going to be run when a security incident has detected. So I have here a cluster up and running, and I execute. It's big enough of. I'm going to add. Okay. Okay. I just deployed Falco using the Helm chart and enable a nuts output. Also, I create an Nginx deployment, and I deployed these two playbooks, one for deleting the pod when we receive a write error on a write below root. I mean, a file is created on the root file system. And also, I deployed a network isolation when someone writes something on bin directory. Of course, you can subscribe to whatever you want. It's just a pops up model. Okay. This I have here the pods up and running, the Falco ones, the two functions deployed, and an Nginx that I use for demo purposes. So KST. Okay. I'm going to switch. Okay. That's it. The Nginx bin. I open a shell in a container, and for example, update curl. Going to install curl in this container. That's fine. And okay, and I can, for example, curl google.com. Google responds, answering me some things. But if I create a file in foo, under bin, I isolate the network. I'm still inside, the attacker is inside, but I'm not allowing him or her to go out. That's the point. Also, if I detect, for example, I can have a more aggressive security strategy that if someone spawns a pod spawns a cell in a container, just directly delete the pod. And this is done in this case. Pop. The pod was removed. Oh, pods. And just as long as the Nginx is a deployment, this is spawning a new one. So that's the point, that automatically I can answer several security threats. It's pretty cool to solve this kind of problems with function as a services, because it's a function, it's focused, it's pretty easy. And also you can, it's a bit outside of the scope of this talk, but we port this proof of concept to AWS services using an SNS topic and using just Lambda functions. And we did the same for Google Cloud, using Google Cloud PubSub and Google Cloud Functions. And that's everything on my side. If you have some questions or if you miss something, or you want to explain you can find me outside here, or make the question right now.
Est-ce qu'il y a des questions? Some questions.
Oh. That means pretty good or pretty bad. I explained too well or too bad.
So thank you very much.